Good morning, children. Let us solve some examples using the theorems which we have learned in the last class. So I have taken problems from your NCERT textbook, exercise 4.5. Okay. So the first question says that if A is equal to this matrix, 2 cross 2 matrix, then you have to find the adjoint of matrix A. Alright. Adjoint of matrix A, children, you know that it is nothing but obtained by taking the transpose of the cofactor matrix. So I have to form the cofactor matrix, or I have to get the entries, then I'll be able to write adjoint of the matrix. So M11 you have to write M12, M21 and M22 because it is a 2 cross 2 matrix. Yes. So what will be M11? First row, first column you delete. So it will be first row, first column you delete. First row, first column. Now first row, second column. Second row, first column. Second row, second column. Okay. Now A11 will be the position. So this is positive. I am directly writing the answer. Now you are familiar. This is positive position. So this one. This is a negative position. 1 plus 2 is 3. So it will be minus 3. It is also a negative position. So it will be minus 2. This is also a positive position. So no change. Okay. Now how will be adjoint of A? Adjoint of A, you know that it is A11. Now A12 will be here. Right, because it is transpose of the cofactor matrix A22. So now how will I write here? A11, A12, A22, A21 and A22. So this is your question, adjoint of matrix A. Next one. Find the inverse of each of the matrix if it exists. Okay. Now let us use the new formula method for finding this. First let us name it as A. What's the formula for A? Inverse 1 upon determinant of A, adjoint of A. Yes, children. Now why it is asking if it exists? Because you have to find determinant of A. Only if the matrix is non-singular, A inverse will exist. Because if determinant of A happens to be 0, it will not be existing. So let's find determinant of A. You know how to find determinant of 2 cross 2 matrix? 2 3s are 6 minus of minus 8. So it is going to be 14, which is not equal to 0. Therefore, A inverse exists. Now same as the previous problem. Let us find the, let us write this. M11, M12, M21, M22. Because it's a 2 cross 2 matrix. So M11 means first row, first column. M12 means first row, second column. M21 means second row, first column. M22 means second row, second column. You can see, children, all the entries are repeated here. I mean coming ones here. Okay. First row, first column, like that. Now let me write the answers. A11. Position, you know, children. Positive. Position is negative. Position is negative. So sign will change. Position is positive. Yes. Now what will be the adjoint of this matrix? Adjoint of A. You know A11, A12, A21, A22. Okay. Now A inverse is what? 1 by 14. Right? Adjoint of A. If you want, you can simplify this. 3 by 14. This will go inside. Minus 2 by 7. 1 by 7 and 1 by 7. Okay, so this is your A inverse. Okay. Now let us do it for a 3 cross 3 matrix. Same way. Okay, but it will be little lengthy because it's a 3 cross 3. So let us find determinant of A. So determinant of A will be equal to 1, 2, 3, 0, 2, 4, 0, 0, 5. Now you can expand along first column, no? Yes, because here 0, 0 is there. So it will be 1 time 10 minus 0. Right? First row, first column. Then remaining it is 0. So the determinant will be 10. Yes, so not equal to 0. Therefore A inverse exists. Now let us find what is M11. M11 means I think A11 we can write it directly. First row, first column. So it is 2, 5, 4, 0. So 2 5s are 10. So it will be position is positive. So 10. Now M12. M12 means first row, second column. First row, second column. So it is 0, 4, 0, 5. Again 0. Even though it is negative, it is 0. M13. What is M13? First row, third column. 0, 0, 2, 0. Yeah. So again 0. M13. Position is positive, but it is 0. Now you have to find M21. M21 means second row, first column. So it is second row, first column. So 2305. 2305 will be again 10. Position will be odd, no? Sorry children, here it is A, okay? Cofactor. So here it will be 10, position is negative. M22, it is second row, second column. So 1305. I hope you are following children. Second row, sorry, how much it is? Second row, second column. So it's 5. So A22 is going to be 5. M23 is second row, third column. Second row, third column. 1200. Again 0. So A23 will be equal to again 0. Now M31, M32, M33. Okay. 31. Third row, first column. 2, 4, 3, 2. So I'm going to write here 2, 4, 3, 2. 2 4s are 8. 8 minus 6 is 2. So M31 will be 2. Position is positive. 3 plus 1. Third row, second column. 1304. 1304. So again 4 minus 0. Again it is odd position. So minus 4. Third row, third column. Third row, third column. 1202. 1202. So it is again 2. So M33 is equal to even position. Not M33, it's A33. Yes. Now it's a matter of just substituting now. So now A inverse will be equal to 1 upon determinant of A is how much children? 10. So I write here 10. Now let us write A11, A12, A13. 10, 0, 0. 10, 0, 0. What is A21? Minus 10, 5, 0. Yes, minus 10, 5, 0. What about this? 3, 1, 3, 2, 3, 3. If you want, you simplify this. 1, 0, 0, minus 1, half, 0. 1 by 5, minus 2 by 5, and 1 by 5. So this is my A inverse. Okay, if you get extra time now in the exam, to check your answer correct children, you multiply A and this A inverse and check whether your answer is identity matrix. That way also you can check, okay. Now one more we can do. Let us do a trigonometric. First one is finding determinant of A. You can expand along first row or first column. So it is how much? It is going to be 1 times determinant of cos alpha, sin alpha, minus cos alpha. So this is going to be minus cos square alpha minus sin square alpha is equal to minus 1. By the identity cos square alpha plus sin square alpha is 1, which is not equal to 0. For A inverse exists. Now let us find what is our MIs. So M11. Okay. M11 and A11. M12 and A12. M13 and A13. Okay, M11 means what? First row, first column. So what remains? Cos alpha, sin alpha, minus cos alpha. So minus cos square alpha minus sin square alpha is minus 1. So this is also minus 1. Now children, first row, second column. First row, second column. So it is 0, 0, sin alpha minus cos alpha. Just again 0, position is negative, again 0. Now M13, first row, third column. 1 minute, first row, second column. First row, third column. So again 0, 0, cos alpha, sin alpha. Again 0, again 0. Now M21, M22, M23. M21, second row, first column. Second row, first column. So 0, 0, sin alpha minus cos alpha. So it is again 0, because position is positive, no difference it make. M22, second row, second column. See, second row, second column. So 1, 0, 0 minus cos alpha. So it's going to be minus cos alpha, again minus cos alpha. Second row, third column. So it is 1, 0, second row, third column. No? Second row, third column. 0, sin alpha. So it is sin alpha, but it is position is negative, no? So it will be minus sin alpha. M31, M32, M33. So again let us find out. Then M31, A32 and A33. M31 means what? Third row, first column. So it is 0, 0, cos alpha, sin alpha, 0 and 0. Third row, second column. So 1, 0, 0, sin alpha. So this is sin alpha, but negative. So it is minus sin alpha. Third row, third column. So 1, 0, 0, cos alpha. So this is going to be cos alpha. This is going to be cos alpha. Okay, now you have A inverse is equal to 1 upon adjoint of A into your this. Okay, what is M1 minus 1, 0, 0. So you will write here minus 1, 0, 0. The third one is 0 minus sin alpha, cos alpha. What about here? 0 minus cos alpha minus sin alpha. 0 minus cos alpha minus sin alpha. Take minus side inside. So 1, 0, 0, 0, cos alpha, sin alpha, 0, sin alpha and minus cos alpha. So this is my A inverse. Okay. Very easy children, very scoring. Now I will tell you that even if in the exam, if they have not asked you to do using elementary transformation method, then you can follow this method because chances of errors are less here. Thank you children. If you like my video, please subscribe my channel.